In lecture 8 we're going to start graphing in 2 dimensions, and to do that we're going to look at the coordinate plane. And remember, when we created the number line, we used it to reference any point on a line. So we chose an origin and a unit of distance on the axis, and that gave each point an identity corresponding to a unique number on this number line. We can do the same thing for points in a plane. Each point has a unique identity using an ordered pair of real numbers, and these are called Cartesian coordinates. So we start by choosing an origin, and you can see that here, and then we draw a pair of perpendicular axes. And these are perpendicular number lines, and they intersect at our origin. Usually one of them is horizontal and the other vertical, but you can give them any position as long as they're perpendicular. But for all intents and purposes, we might as well assume that one is horizontal and the other is vertical, because if not, we can just change our own perspective to see them in that way. And usually we label the horizontal axis as x, and the vertical axis, or the vertical number line, is y. And we call this the x-axis, the horizontal number line, and the vertical one, we call it the y-axis. And they're placed so that positive numbers on the x-axis are to the right of the origin, and positive numbers on the y-axis are above the origin. And this divides our plane of interest into 4 quadrants, and we call them 1, 2, 3, and 4, labeling in an anti-clockwise direction. And the points on the axes, are not actually in any of the 4 quadrants, but every other point on the page is in one of the 4 quadrants. Now, any point P that I pick on the plane can be given a unique address here. If I drop a perpendicular to the x-axis, then it's above a unique number on the x-axis, which I make the first coordinate of my pair of numbers. So here, if I drop a perpendicular to the x-axis, it cuts the x-axis at A, so my first coordinate is A. And again, if I drop a perpendicular to the y-axis, I get that that cuts the y-axis at a point B, and that's my second coordinate. And so this gives me a unique address or label with an ordered pair of numbers for any point on the plane. If I pick a point on the x-axis itself, then when I drop a perpendicular to the y-axis, it cuts the y-axis at 0, so the coordinates of this point are A, 0, and the A is the point, the number at which it lies on the x-axis. Similarly, if I pick a point on the y-axis, when I drop a perpendicular to the x-axis, I get 0, so its first coordinate is 0, and its second coordinate determines its position on the y-axis. Here it's a B, and it's a positive number. Here are some examples of points and their coordinates. Maybe difficult to see this, but this is a 2, and this is a 4, and this is -2, -4. So these markers on the x-axis occur at each half unit. So this would be 1, 2, 3, and 4. This point is 4, 1. Again, this is 1, 2, and 3. This is -1, -2, -3. So if I choose to look at this point, If I drop a perpendicular to the x-axis, I get a 4, and if I drop a perpendicular to the y-axis, I get a 1. So its x-coordinate is 4, and its y-coordinate is 1. For this one, if I drop a perpendicular to the x-axis, it cuts the x-axis at 1, so its x-coordinate is 1. And if I drop a perpendicular to the y-axis, I get a negative number, negative 2. So its coordinates are 1 and negative 2. Notice that in this first quadrant, both x and y are positive. And in this second quadrant, we have x values are negative and y values are positive. Take, for example, this point. If I drop a perpendicular to the x-axis, I get negative 2, and to the y-axis, I get plus 1. Its x-coordinate is negative, and its y-coordinate is positive. Note that in quadrant 3, both x is less than 0 and y is less than 0. And in quadrant 4, we have x is greater than 0 and y is less than 0. If I take this point in quadrant 4, I get negative 2 when I drop a perpendicular to the x-axis, and negative 1 when I drop a perpendicular to the y-axis. Notice also these points on the x-axis. The x-coordinate is 2. That's how many units it is from the origin on the x-axis, and its y-coordinate is 0. And this is true for all points on the x-axis. The y-coordinate is 0. For all points on the y-axis, the x-coordinate is 0, and the y-coordinate gives you the distance from the origin. So any given point on the plane has a unique pair of numbers associated with it, which give its position on the plane. And conversely, given any ordered pair of numbers, it corresponds to some point on the plane. For example, if I take the pair of numbers, let's say 4 minus 1, its x-coordinate is 4, so it should lie above or below 4 on the x-axis, and its y-coordinate is negative 1. So if I draw the line for all y values equal to negative 1, and the line where all x values equal 4, they intersect at a point, and that is 4, negative 1. Let's try that with some points. Can we plot these points on a Cartesian plane? Well, this is our plane, so let's draw a vertical axis as best we can, and a horizontal axis. We call that x, and we call that y. And now we choose our unit of measurement for both axes. This is our origin. And let's call that 1, 2, 3, 4, 5, and then our negative numbers should be to the left of the origin. And for the y-axis, here we have 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, and negative 5. And obviously this is a rough sketch. Some of these units are not exactly the same as the previous one. They should be. Let's take this point 0, 5. Well, its x-coordinate is 0, so it should lie above the point 0 on the x-axis, and its y-coordinate is 5, so it should be somewhere across from 5 on the y-axis, and there's only one such point. This is the point 0, 5. It's on the y-axis because its x-coordinate is 0. Let's take the point negative 3, 1. Its x-coordinate is negative 3, so it's somewhere above or below the point negative 3 on the x-axis. Its y-coordinate is 1, so it's somewhere to the left or the right of 1 on the y-axis. There's a unique such point right here, and that's negative 3, 1. To negative 3, well, this one has x-coordinate 2, so it's somewhere on this line above or below 2 on the x-axis. And its y-coordinate is negative 3, so it's somewhere across from negative 3 on the y-axis, either to the left or the right of negative 3. So that means it must be right here. This is the point 2, negative 3. Now you should, of course, pause the video and try to draw these other points, and then check if you have the proper solution. Negative 2, negative 2, well, this is somewhere above or below negative 2 on the x-axis. And then its y-coordinate is also negative 2, so it's somewhere across from negative 2 on the y-axis. That means it's right here. And of course that ties in with what we said about the quadrants. It must be in the fourth quadrant, because in the fourth quadrant both numbers are negative, and that's the only quadrant where both numbers are negative. 0, negative 3 has an x-coordinate of 0, so it must be on the y-axis, and a y-coordinate of negative 3, so that places it right here on the y-axis. On the other hand, negative 3, 0, its y-coordinate is 0, so it must be on the x-axis. It must be somewhere on this line where all of the y's are equal to 0, and its x-coordinate is negative 3, so it must be right there. Notice negative 3, 0 and negative 3, 1 have the same x-coordinate, so they're both on the same vertical line.